Okay, so we're starting circles, and there are quite a few things with circles. The notes are going to be a little long today. They're 5 pages, but the first page is just me going through vocabulary and whatnot, so don't stress about it too much. It'll be fine. I just want to see if I could draw lines. It won't let me, so alrighty. So circle set of all points equidistant from a point called the center. Okay, center is named by a point. So if I have this A, then this would be circle A. Circumference is the distance around a circle. That'll come more into play after break. Radius is the distance from the center to a point on the circle. So if I have, let's say, point B right here, this would be the radius. So AB would be a radius. A chord is a segment whose endpoints are on the circle. So if I have C here, this would be a chord. BC would be a chord. Okay, a diameter is a chord that passes through the center. So a diameter is a type of chord. So if I just drew a line across here, okay, then CD would be a diameter, but it is also, CD is also a chord. Okay, so we're going to get to the second piece, our second part of vocabulary. So next thing is called a tangent. I know we talked about tangent in trigonometry. They do have a tie-in, but it's we're not quite ready to explain that to you. It gets a little bit complicated. So tangent is a line that intersects a circle in exactly one point. So it's a line and it can only intersect it in one point. So if I have a point here and I have a line that goes through this point, this is going to be my tangent. So we're going to call this F, and we're going to call this G, and this is circle E. And so F, ooh, why did I write B? FG is my tangent. A point of tangency is the point at which a line is tangent, so that would be point F. A secant is a line that intersects a circle in 2 points. So a secant can actually contain a chord. So secant, the secant actually contains chord HI, but if I write it like this, I'm talking about the secant. Okay, I'm just going to put this over here. If I write HI and I have a segment bar over it, that's actually going to be a chord. So you have to be very careful with your notation. Okay, our next little thing that we're going to talk about are arcs. So arc is a set of all points between and including any 2 points on a circle. So if I have J here and K here, this would be arc JK. And so you write JK and you put a little arc over it. Okay, a minor arc is an arc that measures less than 180 degrees. So in this case, yes, JK is going to be a minor arc. Now what I'm going to do is I'm actually going to write the letter L here. Okay, also KL is a minor arc. A major arc is an arc that measures more than 180 and less than 360, and it is named by 3 points, and you connect them in order, and that'll come more into play as we go through these notes. So a major arc would be if I went from J to L to K. So I would say JLK is a major arc because it's greater than 180 and less than 360. I could not call that JK because arc JK would be the distance from here to here. Okay. Last thing is a semicircle. Semicircle can be named but with 3 or 2 named with 2 or 3 points. Okay. It's just the first and last point are going to be diameters. So we could call this JL. Okay, or we could call this JKL. So those are my arcs. All right, so let's match the following. We have a radius, so AC is a radius, so that would be 1. Diameter is DE, so that would be 7. My chord would be CD, which is 9. My secant that goes through and intersects 2 points, or intersects more than, or intersects in exactly 2 points would be DF, or no, this is actually an arc, isn't it? Would be, oh no, DF. Ooh, this is an arc. Sorry guys, this did not come out right. There we go. And so this is 10. My minor arc is 8, okay, which is CD. My tangent is BC, CG, something like that. That was number 3. The point of tangency is C. An exterior point is G. A major arc would have to be 3 points. It's not a diameter, so D to E to F, that will work, so that's number 2. And a semicircle would be from D to C to E, and if I connect it in that order, that's going to be my semicircle, which is 5. So we're going to talk about arc measure, and then we're going to talk about arc length after break. So arc measure is a portion of the angle measure of the circle. So we know a circle is 360 degrees, so it's just a part of that 360 degrees. It's measured in degrees or radians. We will not talk about radians in this class. It's equal to the measure of a central angle that intercepts that arc, okay, and we'll talk about that. So, and I don't know why these came out so funny. Okay, so the measure of arc CE would be the sum of 34 and 53, which would be 87. Would be 87 degrees. EF, well, that's going to be 180 minus 87, which is 93 degrees. If I'm going from E to C to K, so I'm going to erase these. So I'm going from E to C to K. Well, first thing I have to figure this out. This right here is 180 divided by 3 because they're all the same. So this is 60 and this is 60. So I'm going to add, for this, I'm going to add 34 plus 53 plus 60 plus 60, and I get 207 degrees. Okay, and then DFC, so D to F to C, well, this one right here, this arc right here, it'd actually be better to subtract 53, what's not included, from 360, so that's going to be 307 degrees. Okay, our next topic is central angles in arc measure. The measure of a central angle is equal to the measure of the intercepted arc. So the measure of angle ABC is equal to, if it comes from the center, the measure of arc AC. So for this, what is the measure of arc AC? Well, that is also going to be 39 degrees because the central angle is. The measure of arc AE, which would be this arc right here, is going to be 180 because we have endpoints of a diameter minus 39, which is, so 180 minus 39, which is 141 degrees. The measure of arc EK, so from E to K, so that's going to be a little bit more complicated. We don't know this part right here, except for the fact that we know this angle right here is 39, this arc is 39, so this arc has to be 39. And so that's just going to be 180 minus 39 minus 70, which is 71 degrees. And a measure of angle KBD, well, if this arc is 39 degrees because it's the same as this arc, then this angle must also be 39 degrees. So the measure of a central angle is equal to the measure of the intercepted arc. Okay, so now we're going to get into other rules. So we've learned that if it's from the center, so I know for this diagram, the measure of angle ABC is equal to the measure of arc AC. Okay, our next rule, and we'll write it up here too, okay, is the measure of an inscribed angle. So this right here is called an inscribed angle. Okay, an inscribed angle is an angle whose vertex is on the circle and whose sides are chords. Okay, and I'll make sure that this is in the notes here. So this is an inscribed angle because it's on the circle and the sides are chords, so it does not come from the center. Okay, central angle comes from the center. So the measure of an inscribed angle is half the measure of the arc that intercepts that angle. So for this one, the measure of angle ABC is actually going to be 1/2 the measure of arc AC. Okay, so we're going to use that idea to find the measure of the missing angle. So for this one right here, well, the measure of angle 2 is super easy because if this is 114, this is 114. The measure of angle 1, on the other hand, do you see that this is the intercepted arc? Okay, it's the arc that's in between the sides of the angle. Okay, this is actually going to be 1/2 of 114, which is going to be 57 degrees. Okay, my next one here, so my second example, the measure of my first arc is actually going to be 18 times 2, right? Because if this angle is half of this arc, then this is going to be, then the arc is going to be double the angle, so we could also write it that way. 2 times the measure of angle ABC is equal to the measure of arc AC, if you will. Okay, and so that's going to be 36 degrees. So this is 36 degrees. Once I know what this arc is right here, I can find the measure of this angle here. So what I'm going to do, it's going to be 360 minus 100 minus 134 minus 36, which is equal to 190 degrees. And so the measure of angle 2 is going to be 1/2 because it's the angle of 190, which is 95 degrees. And don't forget your degree symbol like I've been forgetting. Okay. The next problem here, if two inscribed angles intersect the same arc, then they are congruent. So that just says that since basically this angle here, the measure of angle ABC, is 1/2 the measure of arc AC, because you see that the sides intersect. And I also know the measure of angle ADC is 1/2 the measure of arc AC. Then the measure of angle ABC must be equal to the measure of angle ADC. We have another theorem, just something to look out for, is any time an inscribed angle, it intersects the endpoints of a diameter, then the angle has to be 90 degrees. So okay. And the last one is a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So first thing I want to look at is this angle is half of this blue arc here. And I also know that this angle, because it's inscribed, is half of this arc right here. And so, well, if the arcs add to 360, and these angles are half of these arcs, so half of the measures of these arcs, and these are half, then they add to 180 degrees. Okay, so just do a couple examples of that. So for this one here, I know the measure of angle 1 is 64. So the measure of angle 1 plus 64 is equal to 180 because they are opposite. And so therefore, the measure of angle 1 must be equal to 116 degrees. And I also know that the measure of angle 2 is 58 equals 180, so the measure of angle 2 must be 122 degrees. Okay, on to the next one. Now this one's kind of an interesting one. One is actually pretty easy. So first thing you're saying, oh, well, I know that this is 118 and this is 2, and I know the measure of angle 2 plus 118 is equal to 180. So the measure of angle 2 must be equal to 62 degrees. And that one is pretty easy because you know that. And like, wait a second, Miss Holly, this I don't know. But do you see that, remember, we just went over this. These are endpoints of a diameter. So if these are endpoints of a diameter, then this angle right here must be 90 degrees. And if that angle is 90 degrees, then the measure of angle 1 is 90 degrees because 180 minus 90 is 90. This last little example for this one here is I don't know the measure of angle 1, but I know the measure of this arc is 102. So I know that the measure of angle 1 must be 51 degrees because so that's 1/2 of 102. So that's 51 degrees. Sorry, that should be a 5. And then the measure of angle 2, well, I know that the measure of angle 1 plus the measure of angle 2 is equal to 180. Since I know the measure of angle 1 is 51, then the measure of angle 2 must be 129 degrees. Next idea, angle created by a tangent and chord, very similar to our inscribed angle, just super easy. Basically just says the measure of angle 2 here is equal to 1/2 of BD. So if it's an angle created by a tangent and a chord, this angle is half of this arc. Also on the other side, this angle is half of this arc. So the measure of angle 1 is equal to 1/2, and this should be measure of arc BRD. Bert, huh? Okay. So for this one, I know that this angle is half of this arc, so the measure of angle 1 is 1/2 of 112. So the measure of angle 1 is equal to 56 degrees. For this one here, this is a little bit interesting. So the arc is 78. I can find this arc right here by doing 360 minus 78, which is going to be 282 degrees. So the measure of angle 1 is going to be 1/2 of 282, which is going to be 141 degrees. Make sure your angles make sense. That looks like it's about 141. Last two rules and we will be done. Okay, I know that this has been a bit long. So the other thing is, so we talked about if it's central, then it's going to be equal to. If it's on the circle, it's half. Now we have angles if it's inside the circle. So this is called this circle on the inside created by two chords or two secants. You see how these angles, when we know that they're vertical angles, I know that the measure of angle AEB is equal to the measure of angle CED. Now, since it's in between, you're going to take the average. What you do with these is you add the arcs that it's between and divide by 2. That's what you're going to do here. So this angle or this angle, doesn't matter which one you pick. If I take this arc plus this arc, the measure of this arc plus the measure of this arc and divide by 2, I get this angle. And so here's my formula here. So the measure of angle AEB is equal to 1/2 the measure of arc AB plus the measure of arc CD, or I could say the measure of angle CED is equal to the measure of arc AB plus the measure of arc CD divided by 2. Okay, either way, these are the same formulas to get that angle. So for this one, if it's on the inside, it's going to be the average of the intercepted arcs. Okay, they're going to be the inside of each of those. So x is going to be just 107 plus 55 divided by 2, which is going to be 81 degrees. For this one, here's my angle. Here are the arcs that I'm talking about. I set up the formula. I know 71 is equal to my arc x plus my 92 arc divided by 2. Now I just have to go through and solve this. So I end up with, so these divide out, and so I have 142 is equal to x plus 92. I subtract 92, and x is equal to 50 degrees. My last one, well, this angle, I actually don't know these arcs, but I do have information for the angle next to it. I can find this angle right here. We'll call this y. I know angle y here is 82 plus 146 divided by 2. So that y is going to be 114 degrees. And I know that these two angles in a straight line, so x is going to be 180 minus 114, which is 66 degrees. So things that we did first quarter kind of catching up to us. Last but not least are when the angle is on the outside. So we did from the center, okay, which was the same. On the circle is half, inside the circle add and divide by 2, and there's only one rule if it's outside the circle. They're just 3 diagrams when it's outside the circle. When it is outside the circle, instead of adding and dividing by 2, you subtract the arcs. Okay, and you divide by 2. So if I have A, B, C, D, and E, here's our angle, and you see that these are our intercepted arcs. So the measure of angle bad in this case is equal to my big arc, which is CE, minus my small arc, which is BD, divided by 2. Okay, for this one, this is going to be BAD. This is going to be C. Same thing here. I'm talking about these arcs right here and this angle. The measure of arc BAD is still going to be the outer, the bigger arc, so we're going to call that CD. Okay, minus the smaller arc, measure of arc BD, divided by 2. And the very last one, same thing. If we have two tangents, and I'm going to throw a little point right here. We're going to have a C here. And so this is going to be BAD. In this case, the measure of angle BAD is equal to the measure of arc BCD minus the measure of arc BD, just always do bigger minus smaller, divided by 2. So it's just a matter of the formula, just applying the formula. So I have 5 examples. They'll go relatively quickly. So for the first one, here's my angle, here's my arc, here's my arc. I know my angle is equal to my big arc minus my small arc, divided by 2. So my angle in this case is just going to be 32 degrees. Here's my angle, here's my arc, here's my other arc. So I know my angle, and this one we're going to have to solve, is going to be 168 minus x divided by 2. I multiply each side by 2, and so I have 118 is equal to 168 minus x. Do not drop your negative. You will never have negative angle measurement. I subtract 168. I end up with negative 50 is equal to negative x. I divide by negative 1. X is equal to 50 degrees. Okay, and then let's go to this one right here. So here's my angle, here's my arc, here's my other arc. Now we have a little bit of a problem here because we don't know this arc, but we can find y by subtracting from 360. So that's going to be 360 minus 183 minus 93. So y in this case is 84. And then I use my formula. My angle is my big arc, if it's on the outside, minus my small arc divided by 2. And so in this case, x is going to be 49.5 degrees. Okay, find the measure of the missing arc and angle. So for these ones, for the two tangents, okay, here's my angle, here's my arc, here's my other arc. Well, I know that those two arcs add to 360, so the first thing I need to do is solve for my other arc. So this is going to be 360 minus 259, which is going to be 101 degrees. Okay, so this is 101. So I know my angle is equal to always my big arc minus my small arc divided by 2. So my angle is going to be 79 degrees. This one's a little bit more challenging because we have two unknowns. It's asking you to find this, but we don't know either arc. So I'm going to propose to you this. So what if I told you that this small arc was x? Then you would tell me my big arc was 360 minus x. Okay. We could also, actually, we'll just call this, sorry. If I called this x, then this arc right here, I'd take 360 and I would subtract x from it. And here's my angle, okay? I know my angle is my big arc, which is x, minus my small arc, which is 360 minus x, divided by 2. Okay, so we go through and solve. The first thing I'm going to do is I'm going to simplify the top. So it's going to be x minus 360 plus x. Because there's a negative 1 out here, I'm going to distribute, okay, over 2. I add my x's. This is 75 is equal to 2x minus 360 over 2. I multiply each side by 2. That's 150 equals 2x minus 360. I add 360 to each side. 150 plus 360 is 510 is equal to 2x. I take that, I divide it by 2, and I get x is equal to 255. Okay, and I know that that's a lot to remember, but you guys have these notes. I'm actually going to go back up just to make sure. I'm going to put all these in the same spot. So in this case, the measure of ABC is equal to 1/2 the measure of arc AC. This one, since it's on the outside, the measure of angle CED is equal to the measure of arc AB minus the measure of arc CD divided by 2. Okay, and if it's inside like this, then you're going to add and divide by 2. So the measure of angle, let's say AEB, or you could do the measure of angle CED is equal to the measure of arc AB plus the measure of arc CD